Alright, we're looking at page 213, 6-3 from your packet, rational numbers. Alright, what you're going to learn. You're going to learn to show that numbers are rational and to plot rational numbers on a number line. And, of course, your new vocabulary word is going to be rational number. So why do you need to learn this? Well, you see rational numbers when you read prices and ads on the internet or in the newspaper. Rational numbers are also used in athlete statistics, temperatures, and the weights of items. So go ahead and pause me and get this definition down in your note-taking. A rational number is any number that can be written as a quotient of two integers in which the denominator is not 0. Alright, let's look at that again. A rational number is any number that can be written as the quotient. Now that's the answer to a division problem, right? So as the answer to a division problem of two integers, and the denominator cannot be 0. So we have to be able to write it as a fraction in which the denominator is not 0. And basically it's any number that the answer then is a decimal that stops. Irrational numbers, the decimal goes on forever, like the number pi. Alright, so back here, integers, fractions, mixed numbers, and certain types of decimals are rational numbers. And the examples below show how different types of rational numbers can be written as that quotient of two integers. So when you are writing the definition, I'm gonna delete this. Oh, hold on, I'm gonna erase this. You're gonna just write this first sentence. You're gonna stop at this period here. Okay, here are some examples below. 1 2/3. Remember, we need to write it as the quotient of two integers. So we need to write this as a mixed number, and if you remember, 3 is our denominator. That's how many pieces it takes to make one whole, and we have one whole. So you multiply 1 times 3 and add the number of pieces at the top, which is 2, so you get 5/3. So this is a rational number. 4/10, if you can write that as a fraction, it's a rational number, and you should be able to remember that we just say, well, it's in the tenths place, so we put 4/10 and write 4/10. The whole number 2 is a rational number because to show it as a fraction, which is, remember, top number divided by the bottom number, all we have to do is put 2/1. So any whole number, make it a fraction by putting it over 1, because how many pieces does it take to make a whole in this fraction? 1. And how many whole pieces do you have? 2. So this would equal 2. Okay, and the same thing goes for negative numbers. Here we have -8, so put -8 over 1. And then the last one here, -38/100. Again, the 8 is in the hundredths place, so that's your denominator. And then put your -38 above it, and we have -38/100. Alright, let's look at some examples here. It says, show that each number is a rational number by writing it as a quotient of two integers, or the division of two integers. And remember, we learned about fractions and how they are showing, or could be written as a division problem. So for A, 3/4, we would have written in our past lesson 3 divided by 4. Okay, this is a division problem, and 3/4 is a fraction, so it is rational. B, we have -3. It's an integer, and it can be written as a fraction, and you would write the -3 over 1, so it's a rational number also. C is a mixed number, but we can show this as a fraction, improper. So again, 5 pieces to make one whole, and we have one whole, so multiply 1 times 5, add it to the number of pieces you have on the top, so 5 plus 2 more is 7, and keep that denominator the same. So -1 2/5 can be written as -7 over 5, so it is also a rational number. 11 6/100. So here's our place value, the hundredths place, which is why they have 100 in the denominator. And then all you're going to do here is just take that decimal out and write that 1106 in the top here, and it would become rational. And if you think about it, if you wanted to divide that back out, how many times does 100 go into 1106? Well, it goes into it 11 times, and it would leave you with 6 hundredths, or you could write 11 and 6 hundredths. All right, let's look at some more. Okay, look at the top of page 214. Pause this and do that quick check. Do A, B, C, and D, and then hit play when you're ready to check. All right, so it asks you to show that each number is a rational number by writing it as a quotient of two integers. So again, you're writing that fraction. For A, I have negative 6.4, or 6 4/10. So I know since that's a tens place, I'm going to put it over 10. And then remember, I just take that decimal out. So basically I'm writing 64 tenths, and I have to remember to make it negative. If I divided 64 by 10, it would go into it 6 times, and I'd have 4 tenths left, right? Alright, so B is 9, and remember to show a whole number as a fraction. All we have to do is write 9 over 1. And negative 5/7 is a fraction. Just switch it around a little bit by putting that negative 5 on top, divided by the 7. And then D, negative 75 hundredths. Well, this is over 100. Oh, I can't. Hold on. Let me put that over. It's over 100. Let me just put this over here. It's over 100. And we're going to take off the 0 and the decimal. It's just going to be negative 75 over 100. That would be your answer. Alright, it's going on to show you how to plot these fractions on a number line, and we've looked at number lines and fractions before, so it's a little bit of review. Number 2 says plot 4, 6, and 5, 6 on a number line here. So the denominator of, I'm sorry, I didn't see the negative, of negative 5, 6 and 4, 6 is 6. So you want to divide your number line into pieces of 6. So there are 6 pieces that make up each whole, and then make sure you label them 6. For positive numbers, count to the right from 0 and find this 4, 6. So here's 0, here's one whole, and they have been divided into 6 pieces, as you see here. And if you look over to the 4th 6, that would be where you would plot 4, 6. And for the negative numbers, you're looking to the left. So here we're counting over those 5 marks to get to 5, 6, which they have marked with that red dot. And that's that negative 5, 6. So in class, we'll go ahead and do some of these quick checks, these plotting these fractions on the number line, and practice that in the classroom. And we're going to just move on. Okay, let's look at the example. They have plotting decimals on a number line here. Vera owes her brother $1.70. This debt is represented by negative 1.7, or negative 1 7/10. Basically just marked out that 0, right? And since it's a debt, they gave it a negative sign. They want this to be plotted on a number line. The smallest place value in this is the tenths place value, so you want to divide your line into tenths. So if you look at this number line down here, we have 0 and 1, and in between 0 and 1 we have divided into 10 pieces. And the same thing for the next whole is divided into 10 pieces. So for negative numbers like negative 1 7/10, you want to count left from 0. So you move to the 1, and you know you have 7 more tenths. So you count the 1, 2, 3, 4, 5, 6, 7. And this would be your negative 1 7/10. Now they would like you to go ahead and plot these on a number line, but I think we will also practice this in class together. And then there's this little reminder at the bottom of the page that number lines can also be vertical. The positive numbers appear above the 0 on the line, where negative numbers appear below the 0. Think of the thermometer. And as you move up on a vertical number line, the numbers become greater. Okay, the top of page 215 gives you another example of plotting on a vertical number line. Here it says plot -3 on the vertical number line. So you draw the line up and down, as shown over here to the right. Label the integers and count down from 0 to find this -3. Here's 0. And so down 1, 2, 3 would be -3. We're going to skip this plotting and look at the check your understanding. Alright, I'd like you to finish your homework by doing this check your understanding. Name 3 different rational numbers. Number 2, modeling complete each statement. A, on a horizontal number line, negative rational numbers appear blank to 0. This is asking for a location compared to 0, whereas B is asking on a vertical. Now notice this is horizontal, this is vertical. On a vertical number line, negative rational numbers appear where compared to the 0. And then down here, they want you to match these rational numbers, 3, 4, 5, and 6, with the points on the number line. And they give you some red points on there. And then answer number 7, is 0 a rational number? Explain. Right, bring that to class tomorrow to check with your partners. And then bring a question, and I'll see you then.